Hey geometry students, it's Mrs. Fellon. I'm here to talk about lesson 4.2. So I'm on page 99 in your student journals. All right, so this whole lesson is about reflections. So remember we talked about transformations, right? So there are four different types of transformations. The first one we talked about was translations, and so this one would be about reflections. I want to recommend that you grab a note card so that you can kind of use this throughout the course of this unit. And we're going to write some stuff, some reflection rules and some rotation rules when we get to that part on that note card for you. So if you have a note card, I would suggest that you grab it. Okay, so some definitions, like a reflection, and most of you kind of already have an idea of what a reflection is. It is a type of transformation. So I'm just going to write transformation. And then it uses a line to reflect over. It uses a line, I'm just going to put to reflect over. So sometimes that reflection line can be the x-axis or the y-axis, but sometimes that reflection line can be any vertical line or any horizontal line, or even any kind of linear equation, like y equals x and y equals negative x. We're going to speak about some really specific examples when it comes to reflection lines, and then there are some specific rules that I want us to know when it comes to reflecting over these lines. Okay, so a line of reflection is that line that you're reflecting over. A glide reflection is like a composition of reflections. So a glide reflection is a translation. So remember, a translation is what we talked last time, so that way you're either moving left or right, and then sometimes up and down as well. And then it's followed by a reflection. So we talked about this in terms of like composition of functions, right? So composition of transformations, I mean. And so what this is basically getting at is just that we're gonna do two different types of transformations in one. A line of symmetry, what we're talking about here is like if an object has symmetry. So like if I drew, and obviously I'm not 100% perfect here, but let's say I drew a triangle and I said, you know, go ahead and draw in all of your lines of symmetry. You might think of that one, right? But you also might think of this one, and you might also think of, if I can draw it correctly, that one there. So then I have three different lines of symmetry. And so when we talk about a figure that has symmetry, we're going to be talking about the lines of symmetry that it has. Okay, so a reflection is a transformation that's used like a mirror. So we talked about that. And so it maps every kind of point over that line. So what I look at is let's say if I had a point, let's say I had the point 2, 1. Okay, so the point 2, 1. And let's say I wanted to reflect it over the y-axis. One of the ways I do reflections, and there are some rules that we're going to use, but one of the ways we can do this is just kind of count, right? So we know that the point 2, 1 is 2 spaces away from the reflection line. So we can reflect it across, and we know that it's going to be 2 spaces on the other side across the reflection line. So one way of kind of reflecting it would be to just kind of like count the spaces. And a lot of times that comes in handy if you're reflecting it over a vertical or a horizontal line on a coordinate grid, which we're going to be doing a lot. So remember we talked about last time like an image, a pre-image and an image. So remember the pre-image is kind of your starting, and your image is where you end. And so if we had like point A and I reflected it, I'm going to call this A prime. So again, we don't want to call it the same exact thing, so that's why we're calling it A prime. It's a reflection of that particular point. All right, so grab your note cards. These are the rules that we're going to kind of get into when it comes to reflections, and then we're going to practice some of them. So the first one, and these are the 3 that we're going to write down. So what I did is I just wrote on a note card, and I wrote like reflection rules. And so I'm going to show you how to reflect over an x-axis, a y-axis, and then 2 diagonals. So y equals x and y equals negative x. So when you reflect over an x-axis, what happens is, now think about a point, right? So think about we kind of did the one over the y-axis. Think about if you have a point and you're reflecting over the x-axis. So let's say I had the point, 1, 1. If I'm reflecting over the x-axis, that's this one here, and again, we kind of, count the number of spaces, my reflection would be at the point 1, -1. So what happens when we reflect over the x-axis is that our ordered pair, so from 1, 1 to 1, -1, all we really do is we keep the same a value, or x value, right? So we keep the same x value in our ordered pair, but what we do is we multiply the y value by a -1. So it becomes the opposite. So again, if you started here and wanted to reflect it over it, again, you would keep the x value the same and multiply the y value by -1. And so the exact opposite happens if you're reflecting over the y-axis. So if you're reflecting over the y-axis, now I'm going to get the point -1, 1. So notice that if I'm reflecting over the y-axis, that my a value becomes negative. So that's your x value, right? So we're multiplying that x value by a -1, but the b value or your y value is staying constant. So they use a's and b's instead of x and y's, and I think it's because we just don't want to get confused between like all the x's and y's that we're using here. So again, what I want you to understand is that in the x-axis, the only thing that's going to change in your points that you're reflecting is that your y coordinate is going to be multiplied by a negative. And then if you're reflecting over the x-axis, nothing else is changing except for the fact that your x coordinate is going to be multiplied by a negative. When we talk about a reflection in a line y equals x, what I'm referring to here is this is the line of reflection. So y equals x is a line that has a slope of 1 and a y-intercept of 0. And so what we're looking at here is, let's pick a point. Let's say if I pick the point, 2, 0. And what happens is if I reflect it, again, imagine folding it along that line, I get the point 0, 2. So what happened to my coordinate point? So what we're actually looking at here is what happens to my coordinates, my x and y. And if you notice, the only thing that really changed is that they changed spots. And so when you have y equals x, and that shouldn't make sense, because in this equation what we're saying is every y equals every x, and every x equals every y. So basically what you're doing is you're just changing the order. So if I had an ordered pair, even off a grid, and I said I'm going to take, -5, 3, and I want to do a reflection over the line y equals x, my reflection would just look like that. So these 2 points then, would be my pre-image and my image after I reflected it. So all you're really doing is just switching the order. You're switching x becomes y and y becomes x. And then if you're going to do a reflection in the line y equals -x, same deal. So remember, -x is, just basically the same thing, except you're going a negative slope. So again, if you had the point, I'll go with the point, 2, 0 this time. And then it might not be as obvious across there. Actually, it'd be over here, not this one. So if I go ahead and reflect it over here, what happens is my a's and b's, so just like if it was y equals x, they switch spots, but this time, because of this negative sign, we also multiply our x value and our y values by a -1. And so not only do they switch spots, but they also get multiplied by a -1. So if my a value was -5, 3, if I wanted to do a reflection in the line y equals -x, I would get -3, +5. So again, the order changed and I multiplied by a -1. So I'm going to have you kind of write these down just so that you can kind of get used to them, and then you can use them as you kind of go through your practice and then as you're doing big ideas and probably even on the quiz. I haven't decided yet if I'm going to let you use them on the test, but at the very least, we're going to kind of use them as we go along here. All right, I'm going to do some problems. I'm not going to do all of these. I really want to encourage you guys to try the rest of these on your own. And the reason why is because this gets a little tricky, and I really, really, really think that it would be beneficial if you tried a lot of these on your own. All right, so I'm going to do 1 and 3 together. I'm going to show you kind of what I'm looking for. So the first thing I'm going to do is it says graph ABC and its image after reflection in the given line. So the first thing I'm going to do is graph ABC. And so in order for this to fit on my grid, I'm going to count by 2s. So I'm going to count by 2's on my X and 2's on my Y. So if this grid is too small, to grab a piece of graph paper, and that way you can kind of make it the scale whatever you want. The scales they're using here, or the grids they're using here, are awful little. All right, so -1. So again, remember I'm counting by 2's, and then 2, 4, 5. Okay, so that would be where A would be. -4 and 4 would be here. So this is A, this is B. And then -3 and +1 would be here. So that's my original triangle. So that would be, you know, my pre-image, if you will. What we're going to do is we're going to do a reflection over the y-axis. Now you can follow the rule, okay? So I'm just going to kind of highlight the y-axis here. You can go ahead and use the rule if you want, and I'll show you both ways. So the y-axis rule, if you remember, was -a, b. So you can do it that way, or you can do it graphically. So personally, when it's a horizontal or vertical line, I think it's actually easier to do it graphically. I'll show you how. So what I do is, if I'm going to take point A, and I know it's 1 space away from my line, I'm going to reflect it. That means A prime has to be on this side. So that means A prime has to be at the point 1, and then this is the point 5. So 1, 5. And then B is 2 4 spaces away, so 2 4 spaces this way, and this is B prime. So B prime would be at the point 4, 4. And then C prime, again, graphically, I'm counting it's 3 spaces away, so I'm going to count 3 spaces away here. This is C prime. I'm just going to go ahead and draw in my triangle here. And then, so that would be at the point 3, 1. So you can do it graphically and just list your points. What I'm looking for is this kind of end result here. Or you could literally just apply the rule. And so the rule just says, take your A value, multiply by -1, and keep the same B value. Take your A value, multiply by -1, keep the same B value. And so you're just kind of following that process. A lot of times they're gonna ask you to graph it anyway, so sometimes I think it's easier just to kind of do the graphing method. But again, ultimately what you're doing is you're following that rule. Whether you do it graphically or algebraically, it doesn't really matter to me. All right, so what we're gonna do is we're gonna do number 3. And I'm gonna go ahead and start by graphing that original one again. So I'm gonna count by 2's. So that was the original one, or I'm sorry, this one right here. So 2, -1, and then -4, -2 would be right here. So this is B, this is A, and -1, -3, 2, okay. So A, B, and C. Here's my triangle. All right, so it's down there. I'm going to reflect it over the line y = 1. So now here's where you have to use your mad algebra skills here, right? Y = 1 is a horizontal line at 1. So there's the line. So there isn't a rule to follow for this one. So you're going to want to use kind of like the graphing method that I was just talking about. So what you're going to do is you're going to list A prime, B prime, and C prime, because we're going to go ahead and list those coordinates. And then we're going to count. And how far away is A prime from my line, or how far is A from my line? So I'm going to count 3 spaces. It's 3 spaces down. So it has to be 3 spaces up. So that means this is at the point 2, and then 2, 4, 5. So this is at the point 2, 5. And make sure I did that right. So this is at the point, so this is 1, that's 3, and that's 2, 3. Okay. And then B prime is, let's see here, how far away from it is it from the line? So that's 2, that's 4 spaces away from my line. So if you look at this distance here, it's 4. So I'm going to go up 4 spaces and label these. And so this would be at the coordinate point -2, -4. So it'd be -4, comma, and then 2, 4, 6. -4, 6. And then C, I have, let's see here, this is at, from this line, it's 2, 4, it's 5 spaces down. So I want to count 5 spaces up, so 2, 4, 5. So C prime is going to be way up here. And so what we have is I have, let's see here, this is -1, and that's 2, 4, 6, 8. -1, 8. And so those would be the coordinates of my point reflected over this line. So that's kind of in a nutshell how we do reflections. I want to show you a couple other different kinds of problems that I want to do. One's with like diagonal lines. I think that would be helpful. So go ahead and find page 101. That's where we're going to head next. And let's do a couple here. Let's do number 5 and number 7 together, okay? So number 5 and number 7. So number 5 has us doing graph the polygon image after reflection in the given line. So they gave us the original, and they say reflect it in the line y equals x. Y equals x is a diagonal line, and what we're going to be doing is you could apply it. It's easier to apply the rule here than anything else. So it's harder to kind of graph this just visually. It's up to you, but it's still challenging. So what I did is I first listed the points of A, B, C, and D. So I just wanted to list my original points. So again, watch the scales. It looks like they are counting by ones here. So this is A is at the point -3, 1, 2. So -3, 2. B is at the point -1, 2. C is at the point -1, 1, 2, 3, 4. And D is at the point -3, 4. All right, so now what you're going to do is you're going to apply the transformation. And so all you're doing to get to A, and you can, I don't know, we can write it over here. We can do A prime, B prime, C prime. So A prime, all we're doing is switching our A's and B's. So this will become 2, -3 for A prime. B prime becomes 2, -1. C prime will become 4, -1. And D prime will become 4, -3. So literally all I did here was just switch the A and the B value, or the X and Y value. And now all we do is graph it. So 2, -3 is down here. And so this is A prime. 2, -1 is down here. This is B prime. Whoops, I think I did that wrong. Hang on. A prime is 2, -3, and this is 2, -1. Oops, I put B prime in the wrong spot. That's what I thought. Okay, and then C prime is 4, -1, and D prime is 4, -3. Oops, down here. Goodness, I'm really kind of messing this one up. This is why you should use pencil and not pen. All right, so anyway, I graphed it a little, a little rough, but anyways, that's your reflection over that line. And so again, I think it's really easy if you do this with the rule, but what I'm going to be looking for is that you have these coordinate points correct. So I think it's helpful to kind of start. Here's your starting point, here's your ending point. So I will be asking you for like your A, B, C, and D coordinates, and I'll be asking for A prime, B prime, C prime, and D prime. All right, let's do a combination one, okay? So let's do number 7. So JKL says vertices 3, 1, 4, 2, so it's a triangle. 1, 3, and then it says you're going to reflect it, and you're a translation and a reflection. So remember, that's a glide reflection. So the first thing I'm going to do here is I'd like to use your coordinates. So I'm going to start with J is at 3, 1, K is at 4, 2, and L is at 1, 3. So the first thing I'm going to do is I'm going to reflect, or I'm going to go ahead and apply the first translation. Well, actually, maybe first I'm going to go ahead and graph this. So this time they're counting by 2s here, so be careful. So 3, 1 would be about right here. 4, 2 would be here. It's going to be tiny. And 1, 3 is right here. So this is super small, but that's the way it is. So that's my first, that's kind of my pre-image. It's where I'm starting. So next I'm going to do a translation. So remember, if you do a translation, all you're doing is taking your X values and you're subtracting 6. So if I subtract 6, I get -3, and you're taking your Y value and you're subtracting 1. So I'm going to do that for all of them. Subtract 6, subtract 1. subtract 6, subtract 1. And now I'm going to graph this one. So this is the -3, 0, so that's here, -2, 1, and -5, 2. So after my translation, make sure it looks like a translation. So remember, all we really did is slide this one, okay? That's all we did here was slide it. All right, next one, we're doing a reflection in the line y equals -x. So if you want to draw in your reflection line, you can. That's that one. And so a y equals negative x is the rule -b comma -a. So I'm going to call this J double prime. Now that sounds weird, right? But what we're doing is this is the next transformation. So if we have JK, now we have J prime, K prime, L prime. Now we're going to have J double prime, K double prime, and L double prime because we're doing two separate transformations. All right, so all I'm going to do here is switch these around and multiply them by -1. So this becomes 0, +3. This becomes -1, +2. This becomes -2, +5. And then the last thing I'm going to do is graph this. So 0, 3 would be right here. -1, 2 would be right here. And then -2, 5 would be up here. And so that would be your reflection across the line. The graphs are a little hard, I agree. And again, I think it'd probably be easier if you graphed it on a larger piece of paper, but I didn't have the luxury of having that. So I mostly care about that you're doing, like, I'm gonna be checking that you have this stuff correct, right? So I'm gonna be looking that you have the right coordinate points. The graphing is a bonus, and I think it's an aid to kind of help you, but it's mostly about your ability to translate those points. The only other thing I'm going to do here is on these ones, I want you to draw in a line of reflection. And so what they're looking at here is a line of reflection would be something like this. If I put a line down the middle of that O and I fold it on that line, then this half and this half would match up. Same thing with kid. If I put a horizontal line right through the middle, the top half and the bottom half would match up if I folded along that line. So I would like you guys to try, I think it's important that you try like 6, 8, 9, and 12. You can skip number 13, but I'd like you to try the other ones. And I think that will give you some good practice going into our next section, which is rotations. All right, try some stuff, ideas. If you have any questions, let me know.